So this is half past paper week 9. We've got all the odd numbers this week and it is 39 marks in total. So let's get into it. Higher tier, Sparks codes on the front as always. Question number 1, solve 14n is greater than 11n add 6. So what we're going to do is put our dotted line where the inequality symbol is. Now a lot of students prefer to change inequalities to equations. So you might want to write 14n equals 11n add 6. It's the same process as solving an equation. It's all exactly the same, but what students forget to do is then put it back as an inequality. So I would say it's better just to stick with it as it is, but if you'd prefer, just please don't forget to put it back at the end. So the first thing we're going to do is subtract 11n from both sides. It feels like we want to take away 6 because that's what we usually do, but if you look carefully, we've got n's on this side, n's here, and then this is just a constant term. So subtracting 6 is just going to put it on the other side. It's not going to be very helpful. So we want to kind of get all our n's together and all of our numbers, our constant terms together. So I'm going to take 11n away from both sides. And that leaves me with 3n on this side is greater than 6. And if 3 lots of n is greater than 6, I can just divide both sides by 3 and get n is greater than 2. There we go. So that's my final answer. N is greater than 2. If you'd solved the equation, it would have been exactly the same. Minus 11n from both sides. 3n equals 6. Divide by 3 is n is 2. But then don't forget to put it back. I would personally stick with it as it is so that you don't forget that final step at the end. Part B, on the number line below, show the set of values of x for which minus 2 is less than x add 3, and that is less than or equal to 4. So I've got 3 parts here. And I'm going to put dotted lines just to show you. X add 3, this expression in the middle here, needs to be bigger than minus 2 and less than or equal to 4. So when I add 3 to a number, it needs to be bigger than minus 2 and less than or equal to 4. So rather than adding 3 to a number, let's just get the number. If when I add 3, it needs to be bigger than minus 2 and less than or equal to 4, then what I want to do is take 3 away to find out what that x needs to be between. So if I take 3 away, I just get x needs to be bigger than. Now if we're taking 3 away from minus 2, that's minus 5. And if we're taking 3 away from 4, that's 1. The symbols stay the same. So we now know that x needs to be bigger than minus 5, but smaller than equal to 1. So we put a circle above both of those values, like that, and then join them up with a line. And if it's equal to, we colour that in. Now, I remember my year 11 teacher saying to me that there's a little man on the line and he's got a pen. If he can reach it, then he can colour it in. And if he can't reach it, then he can't colour it in. Yeah, that's just stuck with me. So that would be your answer. Colour it in if it's equal to, and if it's not equal to it, then you can't colour it in. Question number 3. Hannah is planning a day trip for 195 students. She asks a sample of 30 students where they want to go. Each student chooses one place. The table shows information about her results. So she's asked 30 students. If we add up these values, it makes 30, but there's 195 students going on the trip. Work out how many of the 195 students you think will want to go on the theme park. So the theme park, 10 out of 30 students chose theme park. So we want that fraction of 195. So if 10 out of 30 chose theme park, we want that fraction of, is times 195. Equally, you can just say, well, it's a third, so I could just divide 195 by 3, and that would make sense as well. So whatever way you want to do it, you can just type that in your calculator like that, or just do 195 divided by 3, and typing that in my calculator, I get, help if I turn it on, 195 divided by 3 is 65. There we go. So 65 students going to the theme park. State any assumption you made and explain how this might affect your answer. So we are assuming that the 30 students she has asked, this sample that she's taken, are representative of the population. So that's a really important thing to say with sampling. You need to ask a mix of people. If she's taking 195 students from year 7 up to year 11, year 7 up to year 11, and then she only asks year 7s where they want to go for her sample, that might not be representative because we're going from year 7 up to year 11 and year 7s might think differently. So what we need to say is that we have assumed that the sample is a true representation or a good representation representation of the population, or of the 196 people going. Okay, we've assumed that the sample is true representation of the population. If it wasn't, because it says we have to say if it wasn't, then the proportions may be incorrect. So it might be that one of them might be more popular if you asked older students or what have you. Fabulous. Question number 5. ABC is a right-angled triangle. Calculate the length of AB. So I'm going to pop an X over here. That's what we're trying to work out. Remember, this is SOHCAHTOA. I know it's SOHCAHTOA because I've got a right-angled triangle and I've got an angle involved. I've got sides involved. So I'm going to put SOHCAHTOA. There we go. And we label our sides first. So let's label the sides of our triangle. This is your hypotenuse. Your hypotenuse is always over from the right angle. You then want to imagine you're stood here in this angle and you're going opposite to find your opposite. So that one's the opposite. And then next to you, that's the adjacent. And the adjacent is always between the angle you're interested in and the right angle. So there we go, we've got our 3 sides. Now, which sides are involved? The opposite is what we're trying to work out. So that definitely needs to be involved. The hypotenuse, I know it's 16, so that's going to be helpful information. The adjacent, I don't know how long it is, and I don't want to know how long it is. So it's not giving me valuable information, and it's not the thing that we're working out. So that's not involved in this question. This question is involving O and H, and that tells me that we're going to be using sine, this SOH triangle here. Okay, fabulous. Cover up the thing you want to know and do the sum that's left behind. So if I cover up the opposite, which is what we're trying to work out, I'm left with S times H. Now remember, the S stands for sine of the angle, which in this case is 38. The C stands for cos of the angle, and the T stands for tan of the angle. So whichever one you're using, you just use sine, cos or tan, and the angle goes in that. And then here we're doing S times H, so sine 38 times by H, that's the relationship I've got there, which is 16. So you can either type that as 16 sine 38 in your calculator or sine 38 times 16, doesn't make a difference which way round. There we go, so I get 9.850583605. It says to 2 decimal places. I would always write it all out and then I'd round it. So 9.85 as my final answer. Does that make sense? Well, yeah, I was expecting a number smaller than 16. 16 is my hypotenuse, so it can't be bigger. So that makes sense as an answer. Question number 7. £360 is shared between Abby, Ben, Chloe and Dinesh. The ratio of the amount Abby gets to the amount Ben gets is 2 to 7. Chloe and Dinesh each get 1.5 times the amount that Abby gets. So let's do a ratio here, A to B to C to D. And the ratio of Abby to Ben is 2 to 7. Chloe and Dinesh each get 1.5 times the amount that Abby gets. So Abby gets 2 parts. If we times that by 1.5, 1.5 lots of 2 is 3. So Chloe is getting 3 parts and Dinesh is getting 3 parts. It says they both get 1.5 times whatever Abby gets. Work out the amount of money that Ben gets. So we're sharing it equally between all of them. Now, if you want, you can draw little lines here. I know a lot of you find that very helpful. So Abby gets 2 piles. Ben, 3, 4, 5, 6, 7, gets 7 piles. Chloe gets 3. And Dinesh gets 3. So if you find that helpful, by all means do that. When the numbers get bigger, it's a little bit trickier, but that's okay. It's just about okay. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So adding all of these together, I've got 15 little piles of money. So I'm going to take 360 and divide it equally between 15 piles. And I feel like that's 24. 360 divided by 15 is 24. So putting 24 on each of those little lines, and then you can work out how much each person gets. Now, actually, they don't care how much each person gets. They just want Ben's share. So Ben is getting 24 multiplied by 7. And you don't need to add it. You can just times it. So 24 times 7. 7 times 4 is 28. And 7 times 2 is 14. Add the 2 is 16. So there we go. 168 for Ben. You could work out each of their share, add it all up and check that it makes 360. But I'm happy we've got the right answer there. So well done. £168 for Ben. Question number 9. Now, this question is actually quite tricky, given how early on in the paper it is. I think this is quite a hard one, so bear with me on this one. The circumference of circle B is 90% of the circumference of circle A. Find the ratio of the area of circle A to the area of circle B. So firstly, the circumference, that's length. We're talking about lines here. So that would be the linear scale factor. Now, the linear scale factor of A to B, it says that B is 90% of A. So I'm going to put 1 to 0.9. The ratio of A to B is 1 to 0.9. Whatever A is, B is 0.9 of it, because it says it's 90% of it. So then the area scale factor is that value squared. Okay, you might at that point choose to get rid of the decimals, but let's just bear with it for now. To get from the linear scale factor to the area scale factor, we square those values. So 1 squared is 1, and 0.9 squared is 0.9 times 0.9, so 0.81. So if the lengths are 90% of the of A, then the area is going to be 81% of the area of A, and that's the ratio, but we can't leave decimals in it. So what I'm going to do is I'm going to times it by 100 to make it 100 to 81, just so I don't have any decimals in my answer. And you could have done that at the beginning. You could have said, well, the lines are in the ratio 10 to 9, because that's 90% of 10. Or you could have said it's 190. It doesn't make any difference with a ratio. So 100 to 81, that is your final answer. Very tricky. You need to be aware of different scale factors for area for that one. Square E has side of length E. Square F has sides of length F. The area of E is 44% greater than the area of square F. Work out the ratio of E to F. So this time, with E to F, they're asking for the ratio of the lengths. So your linear scale factor, that's what they're asking for. Now we know the area, so let's go to our area scale factor, of E is 44% greater. So I'm going to do 1.44 to 1. If I wanted to go from F to E for area, I'm going to times by 1.44. Now you might at that point choose to times by 100. In fact, yeah, let's do that. 144 to 100, just to make that a little bit easier. And you'll notice that these are both square numbers. And that's because when we go from the linear scale factor to the area scale factor, we square those values. So if we're going backwards, we need to square root. So I'm square rooting both of those values, and that gives me 10 on this side and 12 on this side, going from here to here. You could do it with decimals. It would be 1 and then 1.2, and then we could sort it out, but I think that's probably the quickest. 12 to 10, it doesn't say to simplify your answer, so 12 to 10 would be absolutely fine on the answer line, but if you did simplify it, 6 to 5 would work there as well. Very, very tricky for so early on in the paper. It can happen, so don't be put off by it, just have a go. Okay, cumulative frequency. So I've just zoomed out for this one because it's cumulative frequency. We need to fill out the table on the left and then draw the graph on the right. So the group frequency table gives information about the times in minutes that 80 office workers take to get to work. So with this table, just to understand it a little bit better, frequency means how many people. So frequency is how many people. And we've got 5 people that take between 0 and 20 minutes to get to work. So we don't know how long it takes them. It might take them 2 minutes. It might take them 19 minutes, might take them 20 minutes. We don't know. And the equal to at this end means that this can equal 20. And then as soon as you go over 20, you're in the next category. Okay, so that's 5 people that take between 0 and 20 minutes, but I don't know exactly how long it takes them. We've got 30 people that take between 20 and 40 minutes. Now, for a cumulative frequency table, you'll notice the table's a little bit different. Instead of going 0 to 20, 20 to 40, we're still going 0 to 20, so that's fine. We know that's still 5 people. But then we're going 0 to 40. So how many people were there going from 0 up to 40? Well, we've got these 5 people, but we've also got these 30 people, because these 30 people took between 20 and 40 minutes. So therefore, we're going to add those 30 people on. So then we know that this category from 0 to 40 would have 35 people in it. For 0 to 60, we want all of the people that took between 0 and 60 minutes to get to work. So that's going to be those 5 people, those 30 people, but also those 20 people. We've already added the 30 to the 5 to get 35. So now let's just add another 20, and that's going to be 55, and so on. So we're just going to add the next number, add 15, that's 70, then add 8, which is 78, and then add the 2. So how many people from 0 up to 120? Well, that's all of the people. We've just got to add on that last 2, and that takes us up to 80. Now, if you check in the question, they normally, yeah, they have done, tell you how many people there are altogether. We asked 80 office workers how long it took them to get to work, so we would want that number to be 80. If it wasn't, we'd know we'd done something wrong. And we now just need to plot it on a graph. Now, you guys will know, if I ask you to draw a frequency polygon, I often talk about Polly the shark, because a frequency polygon ends up looking a little bit like this, a little bit like a shark fin. This is not that graph, okay? But we're going to go, and Polly the shark lives in the middle of the ocean. Remember, you go in the middle of the category for frequency polygon. For cumulative frequency, you add it up, and then you plot at the top. So everything is up, up, up. Add at the top, plot, add it up, and plot at the top. So it's going to make a smooth S-curve, something like this. Oh, I've run out of room on that page. Something like that. And we just plot at the top of the category for each of these. So I'm going to plot 5 at 20. I'm going to plot 35 at 40. I'm going to plot 55 at 60, and so on, okay? So you're using the top of the category because it's everything up to 20, everything up to 40, and so on. So I'm going across to 20 and up to 5. Let's just zoom in a bit like that. Across to 20, up to 5. So be as accurate as you can. You're allowed, I think, to be within the square. So be really accurate. It'd be a bit bigger and a bit easier on paper. Across to 40 and up to 35. Across to 60 and up to 55. Across to 80 and up to 70. Across to 100 and up to 78. And across to 120 and up to 80. Now pay close attention. It is going up in 2s. You've got 5 squares from 70 to 80, so that's why I plotted 78 1 square down from 80, because there's 2 in each square. And then we join this up with a nice smooth S-curve. Now they do not mark you down for joining to the origin, but you don't need to, okay? So you can either do this, or not join that first point to the origin, but you do need to connect them all like that. There we go. Or that could have been a little bit higher there. I could have done that slightly better. In fact, let's go back and do it so it is perfect. Oh, I've done the same again. There we go, that'll do. I think that's okay. Use your graph to find an estimate of the percentage of the office workers who take more than 90 minutes to get to work. So the lovely thing about a cumulative frequency diagram is that it matches up the values with the position. So if I wanted to know, I've got all of these workers in order from those that took the least amount of time to get to work to the most amount of time to get to work. If I wanted to know how long it took the 50th worker to get to work, I'd just read across, hit the graph, go down, and we'd say, oh, it took them 54 minutes. So I can get the position of any worker and how long it took them to get to work. Here we've been asked to find how many office workers took more than 90 minutes. So I'm going to go to 90 minutes. This side is minutes. And I'm going to go up to my graph, hit the graph and go across. And it gets me 74. Now your answer might be slightly different, but that's okay. Should be about that though, shouldn't be too far out. 74. So how many took longer than 90 minutes to get to work? Well, that's just the people above. 74. These 74 people match up with these times. So they took less than 90 minutes, but it's the people above this section here where they took these times, okay? So we know that 6 people out of 80 took longer than 90 to get to work, or we're estimating that 6 out of 80, and we want that as a percentage, so I'm just going to times that by 100. So in your calculator, typing 6 out of 80 times by 100, and that gets me 7.5%. There we go, that's that question. Question 13, and this one looks really scary, but I promise you it's not so bad. We're dividing fractions, so there's marks available here. You guys will know that if I gave you 3/4 divided by 2/3, you would change that to 3/4 times 3/2. When we divide by a fraction, we times by the reciprocal, keep, change, flip, or however you want to remember it. So let's have a look at it in more detail. So with this question, we are doing x add 5 divided by this fraction. Let's ignore the 6 for a minute. And so if you wanted to, we could get some marks for just putting I'm going to put x add 5 over 1, just because I want to keep it as a fraction, times by x minus 1 over x squared add 3x minus 10. We know that instead of dividing by a fraction, we're going to multiply by its reciprocal. And then this is a quadratic, and this can be factorised. So I'm going to go ahead and factorise that. Always when you're simplifying algebraic fractions, you want to factorise everything you can. So let's make that 6 over 1 add x add 5 over 1 times x minus 1, and then that denominator, that quadratic, is going to become, I need two numbers that add to make 3 and times to make minus 10. That's going to be add 5 and minus 2. There we go. Now luckily for us, we can now see that that's going to cancel. Next row, let's write 6 over 1 add. Now because this is multiplying, I can say it's all of this is being multiplied together and all of this is being multiplied together. So you can write it as x add 5 times x minus 1 over x add 5 times x minus 2. And then we can divide the top of the fraction by x add 5 and divide the bottom of the fraction by x add 5. And that leaves us with 6 over 1 add x minus 1 over x minus 2. And I can't add fractions unless I make the denominators the same. So what I'm going to do to make these denominators the same is I'm going to make both of them out of x minus 2. So this fraction is already out of x minus 2. And to make the first fraction out of x minus 2, I've multiplied the bottom by x minus 2. So I also need to multiply the top by x minus 2. Oh, that's not a plus, that's a minus. There we go. And then all together, that becomes 6 lots of x minus 2, add x minus 1, all over x minus 2. You can leave it in brackets or take it out of brackets, it's fine. And we're going to multiply this out. So that becomes 6x minus 12, add, oh, I've left myself no room, let's go the other way. 6x minus 12, add x minus 1 over x minus 2, and that becomes 7x minus 13. So my final answer would be 7x minus 13 over x minus 2 for 4 marks. Looked really scary, but it was just factorising, dividing by a fraction, and then cancelling everything down and adding your fractions at the end as well, making the denominators the same. Question number 15. Make m the subject of the formula. So the first thing I'm going to do is put a dotted line where the equals is, and I'm going to get rid of that fraction. Remember, what we do to one side, we need to do to the other. So I'm going to times by m minus 1 to just get this all on one level. So timesing by m minus 1 gives me f times m minus 1 equals 3m add 4. Now I'm going to expand that bracket out, and that would be fm minus f equals 3m add 4. Now I'm trying to make m the subject of the formula, which means getting the m on its own and everything else on the other side. Here, f was the subject of the formula, so I want that m to be on its own. Now, to do that, I'm going to put everything with an m on one side and everything without an m on the other side. So I'm going to take 3m away from both sides to get fm minus 3m minus f equals 4. And then I'm going to add the f to both sides because that doesn't have an m in it, so I don't want it on the left-hand side. fm minus 3m equals 4 add f. Now I've got an m here and an m here. The only way to get them together is to factorise. So they're not like terms, but to get the m's together, I can take that m outside a bracket and write f minus 3, and then we can just divide by that bracket. So m equals 4 add f divided by f minus 3. And that's my final answer. Now you might have got everything negative. You might have gone the other way, and that would be okay as well. So if you put your m's on the right hand side and your everything else on the left hand side, it would look the same but maybe a bit negative. So you'd probably have minus f minus 4 over 3 minus f, and that's absolutely fine, okay? It's the same answer, everything's just multiplied by minus 1, so no difference there. I just went the way that made everything a bit more positive. Okay, question number 17. There are some small cubes and some large cubes in a bag. The cubes are red or yellow. The ratio of the number of small cubes to large cubes is 4 to 7, and the ratio of number of red cubes to yellow cubes is 3 to 5. Explain why the least possible number of cubes in the bag is 88. So I've got 4 to 7, which means that the number of cubes must be in the 11 times table, because to be able to share the cubes, we can't have a decimal number of cubes, so they must be able to divide by 11, because we've got 11 parts there. And same with these, red and yellow, this adds up to 8. So the number of cubes must be divisible by 11, and it must be divisible by 8. So we're looking for the first number, for the least possible number of cubes in the bag, we're looking for the first number in the 8 times table and the 11 times table. So the number of cubes must be divisible by 11 and by 8. 88 is the lowest common multiple of 11 and 8. 88 is the first number in the 11 times table and the 8 times table. There is no smaller number that can be divided both by 11 and 8. All of the small cubes are yellow. Work out the least possible number of large yellow cubes in the bag. So if we're again working out the least possible number of large yellow cubes, we're working on that assumption that there are 88 in the bag. Now I know that small to large is in the ratio 4 to 7. That adds up to 11. Now, if we're sharing 88 cubes in that ratio, we need to multiply both of those by 8. At the minute, it's out of 11, and we want it to be out of 88. So if we times by 8, we know that there are 32 small cubes and 56 large cubes. Same with the other one, the red to yellow. So red to yellow is in the ratio 3 to 5, which adds up to 8. I need to times that by 11 to get it out of 88 to find out the actual number of cubes. So timesing by 11 is 33 to 55. So we therefore know that there are 55 yellow cubes altogether. They've told me that all of the small cubes are yellow. So these 32 small cubes are all yellow, which means the rest of the yellow cubes, it's feeling like a tongue twister, the rest of the yellow cubes must be the large ones. So if I've got 55 yellow cubes altogether and 32 of them are small, I'm subtracting that away. 5 take 2 is 3, 5 take 3 is 2, so there must be 23 large yellow cubes, and that's the least number there could be based on the fact that there are 88 cubes altogether. Of course, we don't know for sure, that's just the least number that there could have been. Brilliant, 23 would be your answer there. Question number 19. The diagram shows a triangular prism. The base ABCD of the prism is a square of side length 15. Doesn't look like a square, but it is a square. You can see it's 15 that way and 15 that way. Angle ABE, so ABE is a right angle, and right angles, lovely. Angle EAB, that's this one here, is 35 degrees, and we can see all that on the diagram. Okay, great. M is the point on DA, such that D to M, M to A is 2 to 3. So it's just about here in the ratio 2 to 3. Calculate the size of the angle between EM and the base of the prism. Now, whenever you're calculating the angle between a line and the base, you need to draw the line directly that runs underneath it, like that. So we are making a right angled triangle like this, going through the shape. So that makes a right angled triangle. I know that this line is in the ratio 2 to 3. So I'm going to take 15 and share it in the ratio 2 to 3. 15 divided by 5 equal piles is 3. So 2 times 3 is 6 and 3 times 3 is 9. So I know that this is 6 centimetres and this is 9 centimetres from here to here. Now, if I want the length of this line here, I can now just do Pythagoras using the fact that I know that this side is 9 and this side is 15. If you look down on it from above, let's just draw it like this, where this is M, this is A, and this is B. We've just said that that is 9, and we know that this is 15. It'd be a right angled triangle because it's just there is the right angle. And if I want the length of this side over here, I can just use Pythagoras. So for that, I'm going to do 9 squared add 15 squared, and that gets me 306. And I'm just going to leave it at the minute as the square root of 306 because I'm going to go on and use that in a minute. So it's 17.492, but I'm just going to leave it like that for a second, okay? Now, the other side I can get, remember I want this angle. So to be able to work out that angle, I need two sides in that right angled triangle. I now know this side, and the next one I can get is this one over here by looking at the right angled triangle here on the end. So if I draw that out, I know that this is 35 degrees, this is 15, and we can get this side by using SOHCAHTOA. That is your opposite, and we have the adjacent. So O and A tells us to use TOA. If you want the opposite, you cover that up and do the sum that's left behind. So I'm doing tan 35 multiplied by 15. That's going to get me the opposite. So tan 35 multiplied by 15 is 10.5031137. That's really important that you write down all of the decimal places because we're going to go on and use that in a minute. I'm going to keep it in my calculator though. So I know that this side is 10 point whatever I just said, 503, and I'm just keeping that in my calculator. Now, to be able to get the angle over here, the one that we're actually trying to work out for this question, I'm now going to draw out that triangle just so you can see it nice and clearly. So the triangle that we've drawn that we're interested in, I would like this angle. I know that this side is 10.50311, this answer here, and I know that this side down here we worked out as root 306, the one along the floor. If I want the angle, I've got the opposite and I've got the adjacent. So this is going to be TOA, and because we want the angle, I'm doing tan to the -1, and again that opposite goes on the top and adjacent goes on the bottom. So 10.5 blah blah blah, but I'm just going to click the answer button in my calculator over root 306 like that. So shift tan gets you tan to the -1, then use your fraction button. I'm putting my answer at the top and I'm putting the square root of 306 at the bottom. So nothing's been rounded in what I'm typing in my calculator right now. I'm keeping everything super accurate, and that gets me 30.98157,432 degrees. We've been asked to round it to one decimal place, so that would be 31.0, because the 8 would round up, the 9 becomes 10, so 0, carry the 1, 31.0 degrees for 4 marks. That is 3D SOHCAHTOA and 3D Pythagoras, so quite a tricky one, but I don't think it was the hardest one on the paper. I do think that the question 9, I think that was because of how early it was. I think that was probably one of the more tricky ones. So well done if you had a go at all of that. If you've got any questions, please let me know in the comments. It'd be lovely to hear from you. I hope you enjoyed it, and I'll see you next week for week 10.